Alright, last time we touched a little more on quadratics. This time we're going to take a look at rational functions. So, for rational functions, we're mainly concerned with these asymptotes and wholes. So, vertical asymptote is well, let's just test what an asymptote is just in general, in case somebody doesn't know. It's what the function is approaching infinitely but can never actually touch. So we'll get infinitely close. The vertical asymptote, to find that in a rational function, we set the denominator equal to 0 and solve for x. So let's see if we can create an example of that. If we have f of x equals x plus 1, we're setting the denominator equal to 0 and solving for x. If you theorize that this is actually finding the zeros or the roots, you are correct. That is what we're doing. It's just a different way of saying it. So, set the denominator equal to 0 and solve for x. All values received are vertical asymptotes. For the horizontal asymptote, we only look at the highest power of x. And I'm assuming that everyone has put their numerator and their denominator in cascading order, right? Highest power to lowest, going left to right. So 3 scenarios can occur. The highest power of x is the numerator, so there is no asymptote in that case, no horizontal asymptote, that is. The highest power of x is in the denominator, in which case the horizontal asymptote is 0. Or the highest power of x is the same for the numerator and the denominator. In that case, the horizontal asymptote is y equals is you divide the leading integer of the numerator by the leading integer of the denominator. So let's see if we can create scenarios where that might happen. Alright, so let's go down a little bit here so we're not looking at the previous work. If we have f of x is equal to 2x squared plus x plus 1 all over 3x squared. So in this case, the highest power of x is x squared, and we have one in both the numerator and the denominator. When this occurs, we divide the leading integer of those terms, numerator, by the denominator. So we're going to end up with 2 over 3. That is our horizontal asymptote, y equals 2 over 3. Another scenario, we have, let's see, we can make this one 5x plus 2 over 2x squared plus 3x plus 2. So in this case, we have the highest power in the denominator. When the highest power is in the denominator, our horizontal asymptote is y equals 0. For our third scenario, we're going to have 2x fifth plus 3x plus 2 over 5x plus 2. In this case, the highest power is in the numerator. If the highest power in the numerator, or is in the numerator, there is no asymptote. No horizontal asymptote, that is. So, going back to our study guide then, a hole is another scenario. If any factor cancels from the top and the bottom, it's a hole. So you got to be careful for this. So we're going to look for our holes first. If there's a hole, we're going to cancel it out before we look for these asymptotes. So let's see if we can create that scenario. If we have f of x equals x squared minus x minus 2 over x minus 2. So we can factor the top, and that would be x minus 2, x plus 1, all over x minus 2. So before we do anything, we can recognize that there can be a cancel. In that case, we have a hole. So x minus 2 equals 0, x equals negative 2 is our hole. I'm sorry, we added 2 to both sides. Our hole is at x equals 2. Lastly, you're probably not going to see this. I haven't heard of anybody running into it yet, but there is something called a slant asymptote. And to find it, you divide the numerator by the denominator using polynomial long division. Regardless of whatever remainder you find, the top portion is your slant asymptote. So let's create a scenario like this. If we have, well, let's just use the same function we had earlier. So f of x equals 2x squared plus 3x plus 2 all over 5x plus 2. So if we're going to do polynomial long division with this, 5x plus 2, inside we're going to get 2x squared plus 3x plus 2. We look at the highest powers, look at their terms. So to make 5x into 2x to the fifth, we're going to do 2/5 x. And we multiply that through and subtract it, so 2x squared plus 4x over 5, and then plus 0 as a placeholder. And we'll make that 2 a little bit more visible. That's going to cancel out. This is going to end up being, let's see here, 9 over 5x, I believe, and plus 2. To create this, 5x into 9 over 5x, that's going to be 9 over 25. And we don't need to multiply through because that's just going to say that it didn't factor in equally, and we don't care. All we care about is this term right here. So as soon as we run out of x values up here, we're done. We don't need to go any further. And this is our slant asymptote. So our slant asymptote is y equals 2 over 5x plus 9 over 25. And to show you what this might look like, that's positive slope, so, and we have a positive y-intercept, so it's going to look something like that. And we might have our rational function look something like this then. So the rational function is going to approach this line infinitely close, but instead of having our traditional asymptotes, which are vertical and horizontal, this one is coming at an angle, and we call it a slant asymptote. And that should do it for rational functions. Thank you.